How's it going, everybody? I want to make a video update. There's a couple things I've changed to the mill that I haven't really talked about since I've done them. Maybe you've seen it on some of my Instagram posts, the updates that I've done. Maybe you've seen in the comments some of the things I plan to do, but I want to do a little bit of a rundown of how the mill's doing right now, some things I have upgraded, and a couple things that I'm going to upgrade today or work on. So the first of which is my Z-axis motor stepper motor. Right now I have a 980 ounce-inch stepper motor on there, an open loop stepper, and that's been working for me since I put the machine together. I really haven't had many issues. The only negative, and the thing that I've been regretting a bit since I did it, is the Z-axis is quite a bit slower, so the travel speed and the acceleration have been limited on it since I put the machine together. I have the X and Y limited right now to about 160 inches a minute. They can go up to 200, 210 before I get a little binding, and I just put a little factor of safety in there so I don't ever run into missing steps during cutting, because it is an open loop system. So the Z, unfortunately, has been limited to 102 inches a minute, which is quite a bit slower. The Z-axis does travel quite a bit between cuts, so that's something I've always wanted to improve. I also had to reduce the acceleration a lot because the issue I was having is all the way at the bottom of travel when the Z-axis was closest to the table, which is where it spends most of its time cutting. If it tried to wrap it up all the way from the bottom, it would bind, and that would happen anywhere above around 120 inches a minute, which is pretty unfortunate because that's really not all that fast. So I'll show a little bit of that here. Just show I raised it up to 160 inches a minute as the limit right now, and I'll show you kind of some of the indications I got on how I landed on 102. What I'm going to be doing today is replacing that stepper motor with this 1700 ounce-inch stepper motor. Also going to be open loop, so other than replacing these 4 wires and putting this motor on there really isn't going to be any changes to the software that I need to do. But it's almost twice the power of the stepper motor that's on there right now. So I think I should be able to get a lot more speed and acceleration. I'm not so much worried about the amount of power it has or the torque, to drive a drill bit or something like that into the material, because I've never had an issue with cutting. It's getting out of the cut and trying to wrap it between transition moves and to go back to the top of the Z column or top of the Z plane so that I can replace a tool. So this is one thing I'm going to be doing today that I've been putting off for quite some time. A lot more backlash than I'm really comfortable with. I have the X and Y dialed into at most, on the worst day, about 1/1000th of an inch in backlash on the X travel, and then about 1/2 is the max I've ever seen on the Y. And that is plenty good enough for what I need here on the Precision Matthews. Unfortunately, I couldn't get that level of accuracy or backlash in my Z. So in the Z, I have about 7 or almost 8 sometimes thousandths of an inch of backlash, and that's pretty unacceptable for what I'm trying to do with this machine. So I've used backlash compensation in LinuxCNC as a crutch and kind of gotten by for the last year, and I've had good results with that and really haven't had any issues in the cut. I get pretty great finishes and repeatable Z heights, but if I'm doing 3D toolpaths and the Z is raising and lowering during a cut, then that's really just not going to cut it. It's been something I've kind of been avoiding, try to work around it and do constant Z height cuts rather than 3D toolpaths that raise and lower the head while it's cutting. And I'm just kind of sick of working around that. So I'm going to try to fix that today. I'll zoom in here and I'll show you some of the backlash that I'm getting on the machine. One thing that I have noticed while I was putting the machine together and tramming it is there's 3 bolts in the back of the head here, which you may have seen on some of my other videos, and that's what controls the tilt of the head of the machine. Those 3 bolts are what hold the head to the Z-axis saddle, and as I torque those down, I would put really, really light amount of pressure on them. I would put my tram indicator in the machine so I could set the tilt of the head. And what I noticed was while I had them loose and not snug down yet, I would get essentially no backlash in the Z. So it would be, consistent with what I have with my X and Y, about 1/1000th of an inch. And then as I torque them down to their final torque, that would raise all the way up to almost 8,000th of an inch. So I have an issue, or I have a suspicion that that's causing some binding and maybe warping of the Z saddle, and that's the reason for that. So I'm going to diagnose that a little bit today and see if I can get that worked out so it works in my favor. But I'll zoom in here, show you some of the issues with the travel of the machine going up and down, where I get my binding, and then as well I'll show you some of the backlash I get. So thanks for watching. So as I said, I'm going to start off showing you some of the issues that I fell into with the Z-axis traveling. So what I have previously had my Z-axis set to is, again, that 102 inches a minute. And that's this speed right here. And you'll see it's decently fast. It's good enough. I'm going to move my vise out of the way here. And I can get all the way to the bottom of travel here. Hoping my indicator doesn't smash into the table. Yep, so I can get, that's about the bottom of travel. And I can do a rapid move all the way up off the bottom there at 160 inches a minute with the acceleration set at 30 inches per second squared. And I don't have any issues. I get full range of travel and there's no binding in the Z. I can kind of bounce it off the bottom there, and I have no issues with my speed and my Z-axis. So now I'm gonna bump it up a bit. This is 120 inches a minute. And when I get toward the bottom, it never has an issue going down. And right there you can see I had some binding and I missed some steps at the bottom. So I'll try to repeat that again. It's about where it was, and I'm going to try to wrap it off the bottom at 120 inches a minute. And it's just not going to work. So once I get up into the middle of the travel, this is still that 120 inches a minute. I have no issues traveling up and down all the way to the top of travel. But this is 160 inches a minute, and I'll show you that it really doesn't have any issue until we get to the bottom. So this is the speed that I would like the mill to be traveling at, so it's consistent with the other two axes. But as I get closer to the bottom, and I'll go just until it touches, see right there, I'm having some significant binding until I get up a little bit higher. Okay, so now I've got you zoomed in a little, and I'm going to show you the kind of backlash I get. I have no backlash compensation turned on right now. This indicator is a 0.5 thousandths indicator, so every one of the lines you see are 1/2 of 1,000th of an inch. Right now, I'm going to just slowly go down and get to about a 0 position. Okay, I'm going to go past one more time. So there, I'm set on about 0. Now I'm going to switch to 1,000th of an inch increments in step mode, and I'm going to continue moving down in 1,000th of an inch increments. So this should move 2 of those lines every time I push the down button for the Z-axis. And you can see I can very reliably move 1,000th of an inch in accuracy, or I guess that would be my resolution on the Z-axis. So I don't really have an issue with traveling in 1,000th of an inch. The issue is when I try to reverse direction, and you'll see here I'm now going to start tapping in the up direction, the positive Z, and I'll just count out how many 1,000th of an inch clicks I do until we see indicator movement. So that's 1, 2, 3, 4, 5, 6, 7, 8. So there you can see it's about 0.8 of an inch, and then as I continue to go up from there, I can get my normal repeatable movement in the upward direction. So now that I'm have only moved in the upward direction, I'll repeat that again going down. So that's 1, 2, 3, 4, 5, 6, 7, and 8. And on the 8th time, you can see that that moves down pretty accurately. Alright, so it's a couple days later, and I finally installed the 1,700 ounce-inch stepper motor on the Z-axis. I had a couple of stupid issues when I was doing it, caused by myself. So what I didn't pay attention to is the old stepper motor had a 1/2 inch shaft on it, and the new stepper motor has a 14 millimeter shaft. So the zero backlash coupler that was meant for the old stepper motor wouldn't fit over the new one. What I did was what I'm sure most impatient people would do, and that's hit it with a really large hammer until it finally breaks, and then throw your hands up in the air and give up and wait for the next day. So that's what I did here. You can see this is the old 1/2-inch coupler, and it is snapped right in half. It's held together right now with the little tensioner screw, but if I pull that out, it will just fall right in half. So I had to wait. The silliest of things. You break like a $2 part, and then your milling machine is down for 4 or 5 days from a stupid mistake. So I could have just put it back together again and put a boring head in here and bored this out to 14 millimeters, but I tried to take a shortcut, and it took me the long way around. So I finally came through that, and I got a 1/2-inch or a 14 millimeter zero backlash coupler, and the Z-axis motor is on there. Additionally, what I've gone ahead and done is I loosened those 3 bolts on the column so that the tilt, those 3 bolts that hold the head from tilting once you tram it, I loosened those just like a 1/16 of a turn each, and that really helped with my backlash. Additionally, I adjusted the gib on the Z-axis, so I think it's pretty dialed in now, about as good as it's going to get. So the main goal here was to try to add some speed to the Z-axis, and then as well as get a little more resolution in my Z-axis and try to fix my backlash issue. So I have accomplished both of those things. I'm really happy with where it came, and I'll show you the results here. I have it set at 160 inches per minute, the same as the X and Y axis. At about 200 or so inches a minute is where I get binding at the bottom of travel, and I have enough. 40 inches a minute is enough factor of safety in there, margin for me to feel comfortable that, if it rapids down and then rapids back up again, I'm not going to get any binding. And I'll do that testing here. So again, this is 160 inches a minute. Move my vise out of the way. So I can go right down to the table, immediately reverse, and come back up at 160 inches a minute with no issue. So that was a success. And I've got another 3 or so inches of travel past that, but that's as far as I can go with the indicator and the spindle. So I'll zoom you up closer now and see where we're at with my backlash. Okay, so what you'll be able to see here is the backlash that I have set up on the Z-axis. This is with no backlash compensation at all, so I'll just show you where I'm at, and then I'll go ahead and put in that backlash compensation and show you what kind of results I got for a final product. So I'll come down here, and again, this is that same 1/2 thousandths indicator, and that's close enough to 0. I'm switching to 1,000th steps, and I'll keep going down. So it goes down reliably in 1,000th of an inch increments. The resolution is set quite a bit lower than that. I can take 2/10ths of a thousandth pretty reliably. If I try to do 1,000th or a 1/10 of a thousandth of an inch, usually it takes a couple steps before it will actually show movement every time. So I don't bother doing that unless I absolutely have to, and that's plenty of resolution for me. So now I'm going to go ahead and reverse and try to go up, and I'll count out loud how many steps I can get. 1, 2, 3. So 2 and about a half, and that is very repeatable. Again, I'm going to go down now. 1, 2, and on the third every time. 1, 2, 3. So I have about 2.5 thousandths of an inch in lost motion. And I know this isn't the exact way that you would go ahead and dial in or verify your backlash. I should, range past 0 to about, 5 or so thousandth of an inch, try to come back to 0 and then go 5 thousandths or 10 thousandth of an inch in the other direction and try to come back and see which direction I get that lost motion and measure it. I have done that, and again, I get about 2.5 thousandths of an inch, which is is consistent with what you just saw there. So I'm pretty happy with that. I will go ahead and I'll show you if I try to move in tenths increments. So here I'm moving in 2 10,000ths of an inch steps, and you can see again each one of those lines is 5 10,000ths of an inch, and I can reliably step between each increment, but I don't really need that level of resolution when I'm just trying to zero a dial indicator on the table. So I'm happy with where I ended up. So now I'll go ahead and I'll add the backlash compensation and show for you my results. Alright, so I'm back. I've added into the control 2.5 thousandths of an inch in backlash compensation to the z-axis, and I'll show you how that's helped me. So I'll go again around and zero the indicator here, around a couple times. Alright, and now I'm going to step down in 1/1000th of an inch increments. Okay, and right now I'm going to try to go upward. So you can see we're just shy of 5/1000ths of an inch on my indicator there, and 1, and there we go. I stepped up just shy of 4/1000ths of an inch, so that is exactly 1/1000th of an inch step. So again, I'm back at 0, and I'm going to go down, and I'm at 1/1000th of an inch there. So with backlash compensation turned on at 1/1000th of an inch, I can very easily move in both directions in 1/1000th of an inch increments with no issues. So I am very happy with that. All right, for those of you interested in taking a look at my control, this is LinuxCNC that I use for my control software. Again, I have my speed set at 160 inches a minute for full rapid in X, Y, and Z. You can see that right now it's on the continuous jog mode, so I can jog down in the Z or back up in the Z. Additionally, I can do 100,000ths, 10,000ths, 1/1000th of an inch, and then I have it set to 2/10,000ths of an inch as my lowest step resolution. I can go down, you can change these numbers to any values you want. I could have that at 1/10,000th of an inch. Sorry for those of you who have OCD and don't like that I didn't go to 10,000th of an inch, but when I'm set at 2/10ths, I can pretty reliably get steps. When I go to 1/10th of 1/1000th of an inch, I'll typically try to click in the downward direction once or twice until I finally get movement, and I just don't need that level of resolution when I'm trying to step my axis. So now I'll switch over. I have everything up at the home position. I'm going to exit out of LinuxCNC, and I will show you in my INI file. So I was referring to backlash compensation before. That's that number right here. So axis 2 is the Z, axis 1 is Y, and this is axis 0, which would be the X. So in my Z, I have 2.5 thousandths of an inch as my backlash compensation. In my Y, I have 3/10ths of a thousandth of an inch. And in X, I have 1.3 thousandths of an inch for backlash compensation. As you can see, all of them, this max velocity, 2 2/3, is equal to 160 inches a minute. So that's what I have my settings set to on the 3 different axes right now, and that's what gives me those results. All right, I'll have to apologize for the shaky motion. I'm holding this by hand now. Last thing I'm going to show you here is a couple of the other upgrades that I've done to the mill. One thing in my last video that you'll know is I didn't have my low gear range set up appropriately. So if I wanted to get speeds below approximately 1300 RPM, I would have to manually pick a number substantially higher, almost twice that, for setting my speed, and then look at the digital readout of actual speed of the machine so I could get low range speeds. I have fixed that in my control, so you'll see here I just set it to go 250 RPM. Right now the spindle is in the low range, and if you look over, I am at 239 RPM, so close enough there. Again, I'll just change that to 500 RPM. Move the spindle forward, and 496 RPM. And you can see here I'm on the low spindle, and that puts me in low gear. Additionally, some things that I've done, you'll see the Y-axis now has appropriate way covers before, so how it comes from Precision Matthews. Unfortunately, is it comes without any way covers at all in the Y-axis, and that just wasn't working for me. I cut too many small chips. You can see here, these are some nice gold-looking metal steel chips, and then some nice and dark blue here from some cutting that I've done. And those small work-hardened stainless steel chips even will get in the ways, and they really would wreak havoc on the machine. Additionally, I've gotten into doing a couple projects cutting wood. It's not something I try to do often, but every once in a while I get a request. And cutting wood with all the sawdust, even with a vacuum collection system, wood getting into the whey oil and into that whey was just not something I could deal with. So these are from McMaster-Carr. I can add the part number if anyone's interested. This was a 2-foot section that I was able to do the front and the back of the y-axis from with very easily removed on the front. It's just these 2 clips. I removed those and it folds forward so I can clean underneath it, have access to the stepper motor under here, and anything I may need to do. So that's the y-axis way covers that I fixed. For some people that aren't aware, I've gotten asked about tooling a lot before. I am using TTS tooling system. I love it. These are some import, not very good TTS clones. So it's just a 3/4 inch shank. It's not really a TTS arbor. It's just meant to be an ER20 extension. And I felt that I should try these out, and I regret that. So with the exception of maybe some drills that I don't really care about the length too much, I'm going to refrain from using these and use all actual TTS tool holders. And those have served me really well. So that's some of my tooling. Down here I have, my Heimer, some other tools, and some other stuff for just setting up work holding parallels and things like that. The TTS system has been great. I really don't have any complaints about it. My coolant system that I set up on this mill has been amazing. I have used to always run it with both nozzles. I've now gotten to the point where I typically run it with just this rear nozzle on, especially if I'm using any sort of mist coolant. The 2 dueling nozzles had the tendency to blow the coolant away from where I was directing it, just from the competing air force. So now I'm fine with using just one nozzle. If I really need to evacuate chips from a deep hole, then I'll use both of them and turn the air pressure up a bit. But that's been working great. The spindle light that I have here, I purchased on eBay. Sorry, out of focus there. So that works great. I can turn it on and off. That really helps with being able to see my cut and even make some videos. Not that I have the highest production quality here, but definitely helps. So I can link that part number if anyone's interested as well. And that's basically where I'm at. The enclosure has been doing great. As you can see, this was from a quick cut that I did on a Smith & Wesson slide, and it really does a great job. I'd hate to have those chips all over the floor with my wife and kid walking down here to do laundry and things. I do work out of my basement, so a little bit of a disadvantage because I have to keep the shop clean all the time, but that really isn't a bad thing. So